friends. I hope you're having a great day. Today we're going to talk a little bit about animal senses. We're going to start by thinking about the sense of sight. Now, humans, we have fairly kind of mid-sized eyes for our head. We've learned about other animals that have very different eyes, like insects. Bees, we've learned about their compound eyes. And some insects also have ocelli, which are very simple eyes that just help them notice black and white, mostly for shadows, for very fast response. So we're going to learn a little bit through a special book that I have called Animal Senses. And then I'm going to give you some activities to do using your sense of sight. Animal senses, how animals see, hear, taste, smell, and feel. Imagine if your eyes were on two long stalks and you could turn them all around to see and flip them inside out to shut them. That's what a snail's eyes are like. Or what if you stuck your tongue out to smell the air like a snake does? You might taste your dinner by walking on it like a fly, or just feel it with your face to decide if it would be good enough to eat, the way a walrus does. And what if your ears were on your legs like a cricket? These things may sound strange to you, but they're all part of the amazing world of animal senses. In this book, you will learn about the 5 senses: sight, hearing, smell, taste, and touch, and other ways that animals sense their environment. Find out how their special senses help them survive, and compare their senses to yours. Did you know that a cow has 4 times as many taste buds as you? Or that a hawk can see 10 times better than you can? There are lots of activities and experiments to help you discover why animals have these super senses and what it would be like to taste things the way a butterfly does, see like a skunk, hear like a rabbit, and much, much more. Look beside you without turning your head. You can see from side to side by moving your eyeballs, but birds can't move their eyes. A bird has to turn its whole head to look around. Birds have twice as many bones in their neck as you do, so their necks are flexible for all that turning. An owl can turn its head almost all the way around. It can even turn its head upside down. Some animals, such as this handsome frog, can see what's behind them without turning their head. Read on to find out how they do this and why. If you were a frog, you would have very big eyes sticking up from your head. You could lie in the water with only your eyes sticking up above the surface. You could hunt and hide at the same time. Your eyes would be turned to the sides and you could see almost all the way around your body without moving your head. This could help you look out for danger and food. There's a word here I want to teach you. It's a word called adaptations. And this frog's adaptation of having the big eyes above the water, looking out to the side, help it to survive in its unique habitat. And different animals have different adaptations that help them survive. And we'll be talking more about that as we read along. Giant size eyes. Your eyes stop growing when you're about 7 years old, even though the rest of your body keeps growing for many more years. Our eyes are just the right size for us, about 2.5 centimeters, which is about 1 inch across. But some animals have huge eyes. Giant squid, these guys right here, have the largest eyes of any creature. Each eye is about as wide as this page. Large eyes let in more light than small ones, so they help a squid see better underwater where it keeps watch for predators and prey. So that's an adaptation for living deep in the ocean where there's less light. If a squid was born with small eyes, it wouldn't live as long and wouldn't have babies and continue its line of family on. But the bigger the eyes, the more successful they are there. Now this is kind of a fun thing we're going to try. It says, find your field of vision. The distance that you can see around your body without moving your head is called your field of vision. Find your field of vision by following these steps. Number 1, stare ahead with your arms stretched out in front of you. Okay, here's a picture of me with my arms stretched out in front of me, and I'm looking straight ahead. Go ahead and do that. Continue to stare ahead, but slowly move your arms apart to the sides, keeping them straight. Stop when you can no longer see your hands. You have reached the limit of your field of vision. So your arms are first of all straight out, but you move them out further and further to the side until you can't see them unless you move your head. That's your kind of side vision or peripheral vision. You should discover that your field of vision ends where your arms are straight out on both sides of your body. Look at the picture of the frog's field of vision. If you stood in the same place as the frog, you would see only the part between the two lines. So that's here. You would only see this. Deer, squirrels, dragonflies, rabbits, and many fish also have large fields of vision. This helps them to see predators that might be sneaking up from behind. That would be really, really helpful, wouldn't it? Some animals can see better than people, while others hardly can see at all. Try on some different eyes and see what you're missing. Number 1, stand at one side of a room and look at something on the other side. Now look at it again, the same object, through a pair of binoculars to see how a hawk might see it. Hawks can see 8 to 10 times better than we can. This helps hawks that are flying or perched up high to see mice and other small animals on the ground. If you'd like, you can pause the video here, ask your parents for a pair of binoculars, and try looking at something on the other side of the room. You can imagine if you were really high up, that would help you see a mouse that was going to be dinner. Number 2, hold up a kitchen colander up to your face and look through it. That's like the kind of bowls that have lots of holes in them, like to drain pasta or to wash lettuce in. When you look through it, through each hole, you'll see a tiny part of what's in front of you. That's similar to how a lobster or an insect sees. So that's here, and that's like an insect's compound eyes. It's like there's these 7 different little televisions all together, and they're broken apart like that. Those are called compound eyes. Each eye is divided up into tiny sections that see little bits of the overall picture. Insects cannot focus their eyes, so they do not see images clearly. That means like they can't focus, meaning like make one part really clear when it's blurry and change that to look far away or to look closer. Our eyesight is about 80 times better than most insects. Compound eyes are mainly good for seeing movement. Motion alerts the insect to danger or food. Most animals that hunt other animals have eyes on the front of their head, like you. Both eyes focus on the same thing at the same time. kind of like when you're looking through binoculars. That's why it's called binocular vision, both eyes. Bi means both. Ocular is referring to our eyes, two eyes, both eyes. Binocular vision gives these predators better aim. Some animals have an eye on each side of their head. This is called monocular vision. Mono means one. Ocular refers to the eye. So basically each eye can look at different things separately. Monocular vision helps an animal look for food with one eye and at the same time watch for danger with the other eye. So if we look at these animals, here we've got our predator, who is this mountain lion chasing a rabbit. Here we see that the mountain lion's eyes are on the front of its head, facing forward as a predator, whereas the rabbit's eyes are further away from each other. See this big space between its eyes? And the mountain lion has a tiny space. And the eyes are more on the side of the head. That's because it needs to be able to graze all day long and to be able to watch for predators. So he's going to be more of a grass eater that's prey for a predator. So if we look here, we've got a lynx. We've got a bird called a woodcock, a groundhog, a wolf, a porcupine, and a bear. So just by looking at the closeness of their eyes, you can tell which ones are the predators or meat eaters and which ones are the prey whose eyes, like this woodcock's eyes, are very far out to the side. As is the groundhog's eyes are further away, and the porcupine. They are going to be the prey, and our lynx, our wolf, and our bear's eyes are more on the front of their face, and they are the predators. Test your binocular vision. Chameleons use their swiveling eyes to look for food and danger at the same time. When they find something to eat, they focus both eyes on it so they won't miss when they try to catch it. Try this experiment to see how important binocular vision is to a chameleon. Crouch down so that you're level with, that's step 3 over here. I jumped ahead. Let's come here. You'll need a party blower, a tall container like a yogurt container, and a small piece of paper. Place the container upside down on a table. Scrunch the paper into a little ball and put it on top of the container. Crouch down so that you're level with the ball and within about 6 inches of it. 6 inches would be the distance between your nose and the ball. Put the party blower in your mouth. It works like the chameleon's long tongue, which is used to catch insects. Now, close both eyes and count to 10. Open one eye, blow into the party blower, and try to knock the paper off the container. Step 5, do it again, but this time open both of your eyes. You should find that your aim is much better with both eyes open. That's when you're using your binocular vision. Now, I don't have any party blowers at home, and I wish I had one for you to try this out. But you can still see in the pictures, see that difference. When we're using one eye, it's hard to have good aim. With 2 eyes, we can get a lot closer. Here is a special page about night sight, like this skunk and raccoons that are nocturnal. They have very special things about their eyes that help them to see well. So we've learned that our eyes, our body, everything in our body and in living things is made up of cells. And the cells in our eyes, there's two kinds. There are cells that see color, and there are cells that see black and white. Now, nocturnal animals have more of the black and white cells in their eyes than they do the color cells. So, it says here, what else is special about night sight? If you were a skunk, you would have mostly those black and white cells in your eyes. You would have very few of the color cells in your eyes, so you wouldn't see color very well. You would see everything in black and white and shades of gray. Oh, I don't think I would like that. You would have a mirror-like layer at the back of your eyes. Light bounces off the mirror and comes back through the eye, which makes it glow. Oh, I've seen that with my cat. The extra reflected light helps skunks see well in the night. You're going to learn a lot more about your eyes and all the special parts of the eyes as you get a little older, particularly in 4th grade. We learn a lot about the structure of our eyes and how it works. But rainbows are so fun, and I want you to be able to see this page that says you can see all the colors of the rainbow. Many animals can see the same colors as we can, and some can see colors we can't. For example, rattlesnakes can see all the colors above red. So this is called infrared light, and there's more colors that can exist outside of this red zone, but our eyes can't see them. But a rattlesnake can. And then there are colors that go, or light that exists beyond here in this range, and that's called ultraviolet light. And let's see, insects can see ultraviolet light. Seeing infrared helps snakes hunt warm-bodied animals, even in total darkness. The ultraviolet markings on some flowers help bees to find the flower's nectar. So that's why some insects are only attracted to certain colors, and it often appears to them like a bullseye in the way that the coloring shows up with infrared. These insects, some creatures have big eyes, but not for seeing. These are special fake eyes that are used to scare away or confuse enemies or to attract mates. Look at the animals with fake eyes or eye spots below. This is the spicebush swallowtail caterpillar. Which do you think is its fake eye? I think it's this right here. I think this is probably its real eye. And then here is the polyphemus moth with these eye spots here on the edges of its wings. If a bird comes and attacks the wing thinking it's its eyes, the butterfly can still survive. But if its real eyes on its head were attacked, it probably could not survive. And then, of course, we've got here this beautiful peacock with their feathers that have this display of like eye-looking feathers across its back. And look at this toad's backside. That looks like a face on his backside. But again, if he had an attack there, he could survive. So those are adaptations in the colors and the patterns on their body that help them be more successful in nature than they would be without it. Hi friends, you know who this is. This is Barn Owl. Barn Owl really wanted to come say hello because we're going to talk about owls for just a minute. Owls have very special eyes. They need to be able to focus on small little moving animals at a distance. So they, if you notice, their eyes are on the front of their head from binocular vision, just like predators, which owls are predatory birds. And they have special adaptations that help them be excellent hunters. One of them is that their feathers on the edge of their wings they're very special in the way that they're formed, so that when an owl flies, it can be almost silent. And its eyes are very good at seeing at a distance. They can't see very much close in front of their face. They're better at seeing off in the distance at a little mouse that's running through the field, and they can go and swoop in and find a mouse to eat and bring back to their nest. An owl cannot move its eyes within its head. But they have large eyes. Compared with our eyes and our side of our head, owls' eyes are large for the size of their head. And that's because of how important sight is for them to eat and survive. So you are going to be doing an activity called Owl Eyes. And what you're going to do, and this is a little different than the peripheral vision activity that we did, this time you are going to kind of try to freeze your eyes within your head. So in order to see something, you're going to have to kind of turn your head as far as you can one way and as far as you can the other way, but you're going to continue looking straight ahead. I want you to find a special spot in your backyard that can be a sit spot where you can go and get comfortable and you can practice these skills of being quiet, but you have a good view of the area around. It's a safe place, and maybe a place where mom and dad can see you from a kitchen window or the inside of the house, but where you can go, and I want you to sit, and I want you to pretend you are an owl and use those owl eyes. Practice looking out of the corner of your eyes, not moving your eyes, and turning your head, but not moving the rest of your body as you sit there very still and look all around you for any movement. I love doing this when I go hiking because I like to see the animals that are hiding in the forest, the things that other people miss. And that's one of the ways to do it, to sit still, be very, very quiet, and to use your owl eyes. Do that for 5 minutes, and then tell me what that experience was.